Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Tifr, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the ninth CSIR NET physics PYQs of December 2019. Okay, and also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so I'm going to start. Okay, I'm going to start with first question of CSIR NET physics PYQ of December 2019 of the day. Okay, so question is, and these are part C questions we are solving, guys. Okay, so question 1 is, an and alternating current and alternating current IT equal to I naught cos omega t. So this is the alternating current given, flows through flows through a a circular circular wire circular wire loop circular wire loop of radius of radius r, lying in lying in the xy plane in the xy plane, and the and the and centered at the origin at the origin centered at the origin. The electric field the electric field the electric field that is E, which is function of RT, and the magnetic field that is B, which is function of RT. Electric field and magnetic field, okay, are measured are measured are measured at a point at a point R, such that such that R, which is greater than omega, greater than C upon omega, greater than C upon omega, and which is greater than R. Okay, where R is mod R. Which one of the following statements is correct? Okay, which one of the following, which one of the following statement, which one of the following statements is correct? Is which one of the following statement is correct? Okay, so this the electric field. Okay, so this is the electric field. The electric field. The electric field E and magnetic field B are measured at point R, such that R is greater equal to C upon omega, and C upon omega is greater equal to R. Okay, so you need to select the correct option, and options are given. I'll write those options. Option A, the time averaged, the time averaged, the time averaged mod E, which is function of R and T, is proportional to 1 upon R square. Okay, and option B is time averaged, the time mod of E is proportional to omega square, and option C is the time averaged, the time averaged, the time averaged mod of E, which is function of RT, is mod of E as a function of the polar angle, function of the polar angle. Okay, polar angle theta has a minimum theta equal to pi by 2. This is the option third. And option fourth, that is option D. Option D is along the azimuthal direction. Okay, along the azimuthal and centered at origins. Okay, which is centered at origin, that circular loop. And the electric field E, which is function of R and D, and magnetic field B, which is function of R and D, are measured at a point R, such that R is greater than C by omega, and C by omega is greater than R. Okay, where R is equal to mod R vector. Which of the following statement is correct? That's how we need to find out. Okay, very simple question. So here we know since we know that S pointing vector. Okay, so S is proportional to omega to the power 4, that we know. Okay, S is proportional to omega by 4, and also we know that electric field means mod of electric field is proportional to omega square, and mod of magnetic field, magnitude of magnetic field, is proportional to omega square. Oh, you need to note down this. Okay, very important. If you know that, you have solved this question. See how easy this question is, and this is 5 marks question, guys. Okay, so here we know this pointing vector is proportional to omega to the power 4, and E and B are proportional to omega square. Okay, so which option is matching, guys? Here option B is matching, right? Option B is the correct one, because the time averaged, that is E, time averaged E, which is function of R and T, proportional to omega square, means electric field is proportional to omega square. So this is the correct answer, guys. Very simple, right? So now we'll solve next question. Before that, let me just check whether whether I'm audible or not. Okay, I'm just checking. The electric field E and magnetic field V are measured at point R, such that okay, I'm audible. So I'm going to proceed further. Okay. Okay. So question number two. Question number two. Question two is, this is also a good question. So the positive zero, the the positive the positive zero positive zero of the polynomial, means roots of the polynomial. Okay, positive zero of the polynomial of the polynomial of the polynomial fx equal to fx equal to fx, the polynomial is determined is determined is determined using Newton-Raphson method. Okay, using Newton-Raphson method. Newton-Raphson method. Newton-Raphson method using initial guess using initial guess initial using initial guess using initial guess x equal to 1. Okay, let the estimate the estimate the estimate after two iteration after two iteration 0.5%, option B is 5.0%, option C is 1.0%, and option D is 2.5%. Okay, so this is the question. The positive zero of polynomial fx equal to x square minus 4 is determined using Newton-Raphson method using initial guess x equal to 1. Okay, let the estimate after two iteration be x2. The percentage error you need to find out. Okay, very good question. So here we know that Newton-Raphson method, right? The iteration method. There's a formula we know, that is xn plus 1 equal to xn minus fxn upon f dash xn. Okay, f dash xn at x equal to at x equal to xn and x equal to this is okay, at x equal to xn, okay, or we can directly write this one f dash xn. This just in this formula we can write xn f xn upon f dash xn, okay. So this is the Newton iteration formula, right? Okay, so here we'll find first x1, okay. So we have been given first, we will find first we have been given fx, or you can write like this as well, okay. This is like this, xn minus f fx upon f dash x at x equal to xn, okay. You can write it. So fx is given, that is x square minus 4, that is given, right? X square minus 4 is given. So so f dash x is going to be f dash x is going to be 2x, right? So we can find first x1, okay, x1, that first iteration. We can write like this, x1 as per the question, okay, x1, x1, that is we can write, we'll write like this, okay, x1, okay, x1. So this is going to be x and x naught minus x upon f dash x at x equal to x naught, right? X0 is given, guys. Since x0 is given, initial guess, right? Okay. So initial guess is given, that is 1 square minus 1 upon f dash x, 2 into 1, right? We'll solve it. So this is going to be 1 minus 3 by 2, right? So this is 5 by 2. X1 is 5 by 2. Okay. This is very important formula. Newton Raphson iteration. Okay. This is f dash. Okay. Well, now we'll find x2. X2 is going to be x square minus 1, means 25 by 4 minus 1. Okay. Sorry, minus 4, right? Because fx value is this. So we have got x2, that is x2, right? X2 equal to, we can write as per question, x2 after second iteration, right? This is 41 upon 20, right? So now we'll find the percentage. Percentage is after two iterations. So percentage we will find. So that's x2, very easy question. x2 minus 2, x2 minus 2 upon 2 mod into 100%, right? That we need to find. So this is x2 value, we know that is 41, 41 upon 40. We will write 41 upon 40 minus 2 upon 2 into 100%, right? So we'll solve it. So this is going to be 40, right? 40 into, sorry, this is 20, 41 upon 20, guys. 41 upon 20. So this is going to be, we'll take like 20, 20, 40, right? 1 upon 40 into 100 percentage. So this is going to be 2.5 percentage. Okay. So this is the answer, guys. Which option is matching? Let me check. Option D is matching, guys. Okay. Option D is matching to this one. This is the correct answer. Okay. Next question, guys. Next question we are going to solve. Next question is, next question, that is question number third. Question number third is, the following decay process, which of the following decay processes, so these are the processes, decaying processes given, and we need to select the allowed reaction, okay, allowed process. Strong process is allowed, how weak process is allowed, and how electromagnetic process is allowed, okay. That's how I'm going to explain, and in detail I will explain when I will teach you particle physics, okay. So here this is strong reaction, okay, strong electromagnetic and weak reaction, okay, weak weak reactions, okay, weak reaction, strong reaction, weak reaction, and strong electromagnetic and weak, okay. So for that you need to check I I3 and I3 and delta S, okay. So for strong process, I will be allowed, okay. I3 will be that will satisfy the equation, okay. And delta S value is going to be 0, okay. I'll tell you how this value is going to be 0, okay. And similarly electromagnetic I3 will be allowed, okay. I3 will not be allowed, and delta S value is going to be, this is either 0 or plus minus 1. How I'm going to explain. For this reaction I will explain. So I'll check option by option, okay. So first option is, this is k naught, equal to mu plus mu minus, okay, mu plus mu minus, okay. So for that we'll check charge, where is charge equal both charge is equal both side, okay. So here charge is, we are checking charge, okay. Charge is 0 here, and here charge is 1, here charge is minus 1, okay. This is charge is satisfied, okay. So charge left, and the charge in left hand side equal to charge in right hand side, means charge is satisfied, okay. uh, Charge is conserved, okay. Charge is conserved. So here you can say, for a strong reaction, I and I3 are conserved, both I and I3 are conserved, okay, and delta S value is 0. Similarly, for electromagnetic reaction, if reaction is electromagnetic or process is electromagnetic, I is not conserved, I3 will be conserved, and delta S value will be 0. And for weak reaction, okay, for weak reaction, I and I3 are not conserved, okay, and delta S value is going to be 0 plus minus 1, okay. So here Q is conserved. Now we'll check lepton number as mu, okay, lepton number. So this is not this doesn't come in lepton. This comes on pion, right? So this is 0 lepton number, and these are leptons. So 1 minus 1. So this is conserved. Okay, lepton number is also conserved. Lepton number is conserved. Okay, this is 1 and this is minus 1. Okay. Similarly, we'll check I3, mean I3. First we'll check I for cation is half. Okay, how? There are two element in cation, right? In pion, that is K naught and K plus, okay. So there are two elements, right? So how we find out I, 2I plus 1. I'll explain it in detail when I will teach you particle physics, right? Okay. So as are going to be 1 will go this side, and I value is 1 by 2. Okay. This is I equal to 1. And for muon, I is going to be 0 because muon is only one term. Okay, so we know 2i plus 1 equal to 1. 1 will get cancelled. I value is going to be 0. So this is 1 and 1. Okay, I mean to say this is 0 0. I value is 0, right? So 0 and 0. So this is not conserved. I is not conserved. Okay, and now we'll check I3. I3 because there are two element of K1, right? K naught and K plus. Okay, so it means 2. 2 means the value of I is 1 by 2. So these two I3 is going to be minus 1 by 2 and 1 by 2. Okay, this I will explain in detail when I will teach you particle physics, and soon I'm going to teach after because every Sunday I'm teaching you optics. When optics will finish, when I will complete optics, then I'll start teaching particle physics on Sunday because these are small topics and I can easily cover those topics on Sunday. Okay, so I3 is minus 1 by 2. Okay, and I3 because I is 0 for muon, right? Muon plus and muon minus, so these are 0. Okay, so this is also not conserved. Now value of delta s will find. Delta s for this s is, what is the strange number? Okay, strange number, strangeness, my apologies. So s is, for this s is going to be 1 and these are not strange. So for this this is 1 0. How we have got it? This is also not conserved, and so here we can see delta s equal to plus 1, right? 1 minus 0. I'll tell you how we have got this. Okay, hmm. Here how we get strangeness? This is formula. Q, charge equal to I3 plus S plus B by 2, right? B is barrier number, S is strangeness. For if you talk about this K plus, so charge is 0 equal to I3 value is minus half, this one. Okay, plus S, and this is K1, right? It comes in pion, so this K comes in pion, so this is not a barrier number, right? So barrier number is 0 by 2, right? From here S by 2 equal to 1 by 2, so value of S equal to plus 1. In this way we got the S. And for this, for mu, because value is 0, right? For mu is going to be similar, like Q equal to I3 plus S plus B by 2, right? So from here Q is 0, or Q is plus 1, my apologies, Q is plus 1. Q is plus 1, okay? And this is I3 is 0, I3 is 0, for this I3 is 0. And S is this, and this is not a baryon, right? This is 0 by 2, S equal to 2. So for strangeness, for this, I would say, wait, S plus. Okay. So here, the value of mu plus and mu minus, these are leptons, guys. Okay. So for this value, strangeness is 0, guys. Okay. So from here you can see I3, I3 are not conserved and the delta S value is plus 1, right? So here you can see I and I3 not conserved, okay, and delta S value is plus minus, so plus 1, right? So it means this is allowed reaction and allowed weak reaction, okay, or we can say this is an allowed decay through weak interaction. Weak interaction, not reaction, weak interaction. Okay? Strong interaction, electromagnetic interaction, and weak interaction. Weak interaction, okay. So it means this thus Thus this is allowed allowed decay weak interaction. This is allowed decay through weak interaction. Okay, so which this first option is correct. You can check other as well. So only this reaction will be allowed. Okay, and you need to know this chart. Okay, for a strong reaction, I and I3 will be conserved and delta S value is going to be 0. For electromagnetic interaction, I will not be conserved, but I3 will be conserved. Okay, and delta S value will be 0. For weak interaction, I and I3 will not be conserved, and, and delta S value is going to be plus minus 1. 0 plus minus 1. Okay. So this is the question. Next question we are going to solve. Next question is question number 4. Question number 4 is this is also a good question. A metallic a metallic a metallic waveguide a metallic waveguide a metallic waveguide of of square cross section of square square cross section square cross section of side L of side L is excited. So a metallic waveguide, okay, metallic waveguide of square cross section of side L is excited by an electromagnetic wave, an electromagnetic wave of wave number k, okay, of number of wave number k. The group velocity the group velocity the group velocity the group velocity of the group velocity of the TE11 sorry TE11 mode is, okay, group velocity of the TE11 mode is, okay. Options are option A is CKL upon root K square L square plus pi square. Option B is C upon KL root K square L square minus 2 pi square. Option C is C upon KL root K square L square minus pi square. And option D is CKL upon root K square L square plus 2 pi square. Okay, so these are the options. So metallic waveguide of square cross section, okay, of side L is excited by an electromagnetic wave of wave number k. The group velocity of the TE11 mode is, okay. We need to find out group velocity. So I'll solve it. So first we need to know one formula, okay, that is k square equal to, you need to note down and memorize it, guys, okay. Solve questions using this formula and you can easily memorize the formula, okay. So K square equal to 1 upon C square into omega square minus omega mn square. Okay, this you need to note down. Okay, where is omega mn value is c pi root. So this is going to be c pi root m square upon a square plus n square upon b square. A, b are the side of the cross section. Okay, so this is the value. Okay, so omega mn is c pi, is the velocity of light, c pi root m square upon a square plus n square upon b square. Okay, so from here we can from this value of k square c square equal to omega square minus omega square mn, right? So from here value of m square is going to omega square is going to be c square k square minus omega mn square, okay. So we'll find the value of omega mn. Omega mn is going to be, since omega mn is going to be c pi root m value is given, right? So m is 1, omega 1 1. Okay, so we'll find omega 1 1. Omega 1 1 is going to be omega 1 1 is going to c pi m square. M is 1 upon this omega 1 1 is going to be because we have to find the group velocity for TE11, right? TE11. So that's why we are finding omega 1 1. So this value is going to be 2 upon L square, and this value is going to be so this is the omega 1 1, right? So this is omega 1 1 square is going to be c square pi square 2 upon L square, right? So omega 1 1 is this, then value of this 2 c square pi square upon L square, right? This is the omega 1 1 value, right? Omega 1 1. Okay, well, so now from here we can write this value. So omega square is going to be this is very important formula you need to note down, right? Okay? This 2 c square upon L square. Okay, this we can say equation number 1. Okay, now from equation 1 we can differentiate equation 1. Okay, we differentiate equation 1, this is going to be differentiating 1. Okay, so this is going to be omega. Okay, so this is the equation number 2, we can say. Now we'll find value of from 1, again from 1 this. Okay, it is 1 from 1. We'll find value of omega upon k, this value this one. Okay, omega upon k, and this value is going to be root. I'll show you how I found it. So from 1 I'll write first. 1 is this is omega square equal to c square k square plus 2 c square pi square upon c square, right? This one. So from here we can get omega square upon k square, right? K we can take common. So this is going to be c square plus 2 c square pi square upon k square L square. Okay, this will be this value, right? So from here omega upon k value is going to be from here omega upon k value is going to be root this one c square plus this is c square plus 2c square pi square upon kl square, right? This one, this is in the root omega upon k, right? So now we'll find that vg, that is d omega upon dk, vg equal to d omega upon dk, right? This value we have already is going to be c square common, will take c common, right? cc will get cancelled, right? And this is going to be k square, right? kcl upon root or ckl upon root k square l is the k square l square plus 2 pi square. Okay, so which option is matching, right? Let me check. Okay, which option is matching? Option D is matching. Option B, ckl upon ck. Okay, so this is about this question. Okay, there's one more question. Let me just check. Two parallel plate capacitor with 1 centimeter separation, with 1 centimeter separation between the plates, okay, has two layers has two layers of dielectric, with dielectric constant, with dielectric constants k equal to 2 and k equal to 4. Okay, so two parallel plate capacitor with 1 centimeter separation between plates, okay, has two layers of dielectric with dielectric constants k equal to this, okay, layers of dielectric, okay, k equal to 4, as shown in the figure, as shown in the figure below. Okay, if a potential difference of 10 volt is applied between the plate between the plates the magnitude of the bound surface charge density in units of coulomb per meter square at so the magnitude of the bound surface energy, bound surface density in units of C coulomb per meter square at the junction at at the junction at the of dielectric junction of dielectrics is. I'll make a figure, then it will clear. It will be clearer to you. Okay. Is options are number A 250 epsilon 0. Option B is 2000 upon 2000 epsilon 2000 epsilon 0 upon 3. Option C is 2000 epsilon 0, and option D is this is 200 epsilon 0 200 epsilon 0 upon 3. Okay, so these are the options which is given. Okay, I'll make a figure, then it will clear your doubt. The figure is given like this. Okay, this is k equal to 2 and this is k equal to 4. Okay, and this is grounded. Okay, and this is at 10 volt plus 10 volt. Okay, so this is the figure which is given. Okay, so this is two parallel capacitor with 1 centimeter Okay, so this distance is 1 centimeter. It means this distance is going to be 0.5. Okay, this is 1 centimeter. Okay, so this means this distance is going to be 0.5 and this is going to be 0.5. Okay, this one. So a parallel plate capacitor of 1 centimeter separation between the plates has two layers of dielectric with dielectric constant. These are two layers of dielectric and they are with different dielectric constants. Okay, and a potential difference of 10 volt. Okay, 10 volt is applied between the plates. The magnitude of the bound surface charge density at the junction, the magnitude of the bound surface charge density at the junction of the dielectric, means at this junction. Okay, you need to find out. Okay, very good question. So I'm going to solve it. So we know, right, that is a bound surface charge density formula, right? This is sigma b is equal to p dot n cap, right? P is the polarization, this we know. Okay, so here we'll find that v is, we know, v equal to e1 d1 e1 e1d plus e2d. We can write, right? D is this distance, guys. The distance is same. Okay, this is given, distance is same. I can make one figure here as well. Okay, if you want, like this one. this is D, and this is D. Okay, and these are the different ones. This is minus sigma, this is plus sigma. Okay, and these are, and this is going to be, this surface is minus sigma 2 plus sigma 2, and this is minus sigma 2, and this is going to be plus sigma 2. This is very important because the V is going to be total potential, that is E1D plus E2D, right? And so E1 we know, E1 is that surface charge density is sigma. Okay, so E1 is going to be E1 is going to be E1 is going to be this one. We know that formula, right? Sigma upon E1 value is sigma upon epsilon 1, right? D plus sigma upon epsilon 2 D. We know the at any point, right? At any point, there are two parallel plates, right? Capacitor or two charge sheets, right? And in between the electric field is sigma upon epsilon 1, right? Sigma upon epsilon 1, and if it is vacuum, then sigma upon epsilon 0, right? So there's a dielectric field, so that's why this is sigma upon epsilon 1 between this and between this. Okay, so this is going to be V equal to sigma upon so here epsilon 1 value is epsilon 1 value we know, right? Epsilon 1 equal to, we know, that is this is going to be sigma upon 2 epsilon 0 plus sigma upon 4 epsilon 0 D and D. How? Since we know that epsilon 1 is K epsilon 0, right? So K is they given, right? That dielectric constant is given, right? 2. So 2 epsilon 0 and epsilon 2 is K epsilon 0 is equal to 4 epsilon 0, right? So this value is V. And now this value is going to be, we solve it. So this value is going to be 3 sigma upon 4 epsilon 0, 4 epsilon 0 D, right? And V value is already given value 10 volt, right? So 10 equal to this. From here we can find sigma value. So sigma value is going to be 4 epsilon 0 into 10 upon this is going to be 3 into epsilon 0 into D. D value we know 0.5 centimeter, or we can write 0.5 into 10 to the power minus 2 meter, right? Because this distance is clearly you can see this distance is, because total distance is 1 centimeter, right? So this is half of this, right? 0.5, 0.5. Well, so this is going to be, if we solve it, this is going to be 4 into 10 to the power 4 upon 15, okay? Because 10 to the power 3 will take up 10 to the power 4, and 3 5 is 15, okay? So this epsilon 0, okay? This is the value of sigma, okay? Charge density. Now we will find polarization P1, okay? So polarization we know, right? Polarization is P1, P equal to alpha I, right? Alpha is constant, and that value is we know epsilon 0, and here we can write this value is chi even value is, that is 2 minus 1, right? 2 minus 1. So this is going to be epsilon 0 for even dielectric constant is 2, right? So chi equal to k minus 1, right? We know chi value, chi e equal to k minus 1. This we know. Very important question, guys. Whatever point I am writing, note down it. Okay, very important. This one. chi e equal to k minus 1. Okay, so this value is going to be 2 minus 1, 2 minus 1 into E1 value we have already found, right? E1 is equal to sigma upon 2 epsilon 0 for first one, right? Sigma upon 2 epsilon 0 E1. Yes, E1, right? So this value, if you solve it, so this value is going to be sigma by 2, right? And this value is sigma 1 value, because we know, right, this got n gap, right? And so without direction n gap, so it means we can directly write sigma b equal to this value is sigma 1. Okay, similarly this is p1, right? Okay, p1. Now we'll find p2. p2 is going to be same, epsilon 0 chi e2 factor e2, right? So this is going to be epsilon 0 chi equal to 4 minus 1, and e2 value is sigma upon 4 epsilon 0, right? 4 epsilon 0. So this value is going to be 3 epsilon 0, 3 epsilon, sorry, 3 epsilon, 3 sigma upon 4, 3 sigma upon 4. Okay, epsilon 0, epsilon 0 will get cancelled. Will get cancelled. Similarly here, sigma by 2, and this value is sigma 2, right? So because sigma 2 equal to p dot n cap, right? So direction if we take, so this value is going to be this. Okay, 3 sigma upon this. If we take any direction, right? This we know. Okay, so now we have got sigma 1 value and sigma 2 value. So sigma 1 minus sigma 2, that is the bound surface charge at the junction, right? Bound surface charge at the junction of dielectric, right? Dielectric. So this is going to be sigma 1 minus sigma 2, and this value is going to be sigma 1 value is sigma by 2 minus sigma 2 value is 3 sigma by 4, 3 sigma by 4, this one, right? So if you solve it, this value is going to be 1 by 4 minus 1 by 4 into sigma value we have already found, that is 4 into 10 to the power 4 upon 15 epsilon 0, right? This is the sigma value I have already found, this one, this sigma value, surface density, right? So surface density for this, okay? So this value is going to this one, right? So so this value is going to be, if you solve it, sigma 1 minus sigma 2, that is surface charge density at junction, is going to be 4 will get cancelled, and 10 to the power 4, this is going to be minus 2000 epsilon 0 upon 3. Okay, minus 2000 epsilon 0 upon 3. So which option is matching? My sign doesn't matter for this, right? This is the bound surface charge, right? So this is going to be this direction only. So which option is matching? Option B is the correct option. Okay, B 2000 epsilon upon 3. 2000 epsilon upon 3. Okay, so this is the answer. So minus is just showing the direction, right? So value is this 2000 upon 3. The magnitude is going to be 2000 upon 3 epsilon 0. Okay, it's not about direction, it's just a surface charge density. Okay, so this value is 2000 upon 3 epsilon, and this is the correct one, right? Okay, so this is the value, guys. Okay, now just let me check. So this is very good question, guys. Okay, so you need to know these things. Okay, so like the the charge between two sheets, right? We know, that's why we have directly written E1 equal to sigma upon epsilon 1d. Okay, sigma upon epsilon 1d E1. Okay? Okay guys, so this is the value of surface bound surface density, okay, at the junction of dielectric. Okay guys, so I'm going to stop here, and also I would request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay guys, thank